Alright, so today we are doing double angle properties. This is the last part that's on your formula chart. It's at the very bottom of the back page. So we're going to be using that, and along with a lot of other things that we've done before. But before we really start using them, let's prove a couple of them. So using the sum and difference properties, let's prove the following. So sine of 2a equals 2 sine a cosine a. And since I know that this is what I'm trying to have you prove that right-hand side. So I don't want to start with what I'm trying to show you. I'm going to start with what I can do something with. So sine of 2a. How else could you write 2a? And let me go ahead and put 2a in parentheses so it's a little bit more obvious. So sine of 2a, well, 2 a's is like 1a plus another 1a. So I could write it like that, sine of a plus a. Well, now this I can expand using a sum and difference, or a sum because it's a plus sign. So I could use a sum. So that matches up to sine of, let me write this right here, sine of a plus b. So in this case, a is a and b is also a. So sine a times cosine a plus cosine a times sine a. Well, hopefully this isn't much of a surprise to you, but I can reverse this order right here because cosine of a multiplied times a sine of a, that's like multiplying 1 times 2. That's the same thing as 2 times 1. Doesn't matter the order in which you multiply these two things. So if you want to rewrite it just so that it looks a little bit more similar to each other, you don't really have to do this step, but I'm just going to show you very clearly. So if I write sine a first and cosine a second, you can very clearly see that these two things are exactly the same, and you're allowed to add things that are the exact same. So you have a coefficient of 1 right here. So 1 of these sine a cosine a's plus another one of these sine a cosine a's does make 2 of these sine a times cosine a. And so that is exactly where we were trying to go. And so if you look at your formula chart, this is actually the very first identity, is that if you have sine of a double angle, that's called double angle, sine of 2a, you could write that as 2 sine a cosine a. All right, let's do the next one. So make sure you have this down before I erase it. Let me go ahead and start on the next one. All right, so again, I'm going to start with the side that I am going to expand because this is what I'm trying to show you. I don't want to start with what I'm trying to show you. We could actually do something with this and get there again, but I'm just going to show you the most straightforward way, very similar to what we just did. So cosine of 2a is the same thing as cosine of a plus a, which is the same thing, so match it up on your formula chart as cosine a minus sine a sine a. So if you have a cosine and you multiply times another cosine, now you have cosine squared. This is a little bit more straightforward, minus sine squared, which is exactly where we were trying to go. So we have just derived the double angle properties. Cosine of 2a is actually equivalent to 3 expressions that are all commonly used. I can show you this super quickly because it is an extremely easy and self-explanatory thing. Cosine squared a, well, we've said from like day 1 of proofs that this is the same thing as 1 minus sine squared a, and then you still have that minus sine squared a. So now you could rewrite that as minus 2 sine squares a. So 1 minus 2 sine square a. And you could do that same little quick thing to show that last property. All right. So let's go on. Find the exact value of sine of 2x, cosine of 2x, and tangent of 2x under the following condition. So sine of x equals 3 over 4, and we're between pi over 2 for less than x, less than pi. Well, this is telling you where you're going to draw it, because yesterday we worked on general solutions, and remember general solutions, we would say, well, sine is positive. That can happen in quadrant 1, and it can happen in quadrant 2. Well, if I only want one exact value is just one solution, not general solutions, just the one solution. So if you only want one solution, they're going to have to tell you what quadrant you want to belong in. And so that's what this is telling you right here. Pi over 2, that's 90 degrees to pi. So I'm going to be using quadrant 2 because it tells me to. So don't mistake that with general solutions. General solutions, you will be using 2 quadrants, but this tells me what quadrant to go into. All right, so I know that the opposite is 3. The hypotenuse is 4. So I need to do Pythagorean theorem. A squared plus 9 equals 16, so that's 7, square roots of 7, and I am negative. So this is my angle X. Okay? All right, what I want to do now is to find sine of 2x, cosine of 2x, and tangent of 2x. Well, let's start with sine of 2x. Well, from what we just used, we could do a sum and difference and say this is sine of x plus x, but it would take a really long time. If we use the double angle that we just learned, it's going to shorten that up quite a bit for us. So the double angle says that that is equal to 2 sine x times cosine x. So 2 is just a number 2. Sine is the ratio opposite over hypotenuse. And cosine of x is going to be adjacent over hypotenuse. So knowing that these two things are going to be a fraction, I'll go ahead and make 2 a fraction by putting it 2 over 1. So again, sine is equal to, sine of an angle equals the ratio opposite, which is 3, over hypotenuse, which is 4. And lastly, cosine is going to equal adjacent, which is negative root 7, over hypotenuse, which is 4. And now from here, we can just multiply across the top. So 2 times 3 is 6, times negative root 7 is negative 6 square roots of 7, all over 16. And I can actually simplify that a bit more. 6 over 16, both divide by 3, so that gets me, nope, I'm sorry, they both divide by 2. That gets me negative 3 square roots of 7 over 8. So that will be my final simplified answer. All right, now let's do cosine of 2x. So cosine of 2x is equal to, well, we could do, if you look at your formula chart, we could do cosine squared x minus sine squared x. We could do 2 cosine squared x minus 1, or we could do 1 minus 2 sine squared x. It really doesn't matter which one you do in this case. So I'll pick the first one, because that's probably what a lot of people do, is just say pick the first one. So if we pick the first one, remember that cosine squared x, that's equivalent to me just saying, let me write this off to the sides, just so as a quick reminder. cosine squared x is the same thing as you doing cosine of x, taking whatever that answer is and squaring it. So I'm going to find whatever this answer is, just cosine of x, and then I'll square that. And then I'll subtract whatever this answer is and square that. Okay? So coming back to this. So cosine of x. So let me show this. I'm not doing the squared part. I'm just saying cosine of x is equal to negative root 7 over 4. And I'm going to take that answer and then I'm going to square it. So that's what cosine squared x means. Minus, so sine of x is equal to 3 over 4. And I'm going to take whatever that is and I'm going to square it. All right, so let's do the squaring. Negative squared is positive. Square root of 7 squared is 7. 4 squared is 16. Minus 3 squared is 9. 4 squared is 16. 7 minus 9 is negative 2 over 16, which is negative 1 over 8. All right, now tangent, we've learned this a couple of times. I keep stressing this, but tangent has a equation, and that equation is 2 tangent x all over 1 minus tangent squared x. So you could do 2 tangent of x all over 1 minus tan squared of x. So let's go ahead and do that. So 2 tangent of x. Well, tangent of an angle is opposite over adjacent. So 3 over negative root 7 all over 1 minus, and tangent squared, that just says take that tangent answer you just found and square it. All right, so that's 6 over negative root 7 all over. Okay, let's do some work here. 3 squared is 9. Negative squared is positive. Root 7 squared is 7. So 1 minus 9/7. Common denominator. So that's 7 over 7 minus 9 over 7 is 2 over 7. Negative 2 over 7. All right. Now, let's take this answer. So this is where I'm at right now. That's a negative sign. It belongs there. And I don't like fraction over fraction, so I'm going to go ahead and do 6 over negative root 7. If I do times 7 over 2 times 7 over 2, so times 7 over 2. So that becomes 3. So this is answer of, my negatives canceled, 21 over square root of 7. And I believe that should be it. Did I mess up somewhere? I don't believe so. So 21 over root 7. Now, all of that work is really kind of unnecessary because remember that tangent can also be sine of 2x over cosine of 2x. And I already have what sine of 2x is. I found that answer, and it was, so I got to go find it, but that was this one right here, the negative 3 root 7 over 8. So in green, that sine of 2x was negative 3 root 7 over 8. And cosine of 2x, that answer was -1/8. All right, so if I copy, change, flip, or however you say this, 8/-1, 8/-1, these go away, the negatives go away, the 8 and the 8 also goes away, and the negatives went away, and we're left with 3 square roots of 7, which was quite a bit easier to find than the other one was. Now, if you're saying right now at this point, but these two answers aren't the same. This is the answer I got the first time, 21/7, and 3√7 is the answer I got this time around. Well, they actually are the same. And it's because if I rationalize this for you, you would see that they are, in fact, the exact same. Bless me. So this becomes 21√7 all over regular 7, and 21/7 is that 3√7 is still there. So this is your final answer. I would certainly accept this answer, and I'm not going to count off for not rationalizing, but usually doing sine over cosine is a lot easier than doing the tangent, but I would accept either way you do it. All right, let's go on to I'm recording. So let's do example 2. I'm not going to do all of this. There's not anywhere near enough space, but let's just draw the triangle and you can kind of go from there. So the triangle's in 3π/2 to 2π, so that's like 270 degrees to 360 degrees. So this is opposite is cotangent is A/O. So adjacent is 3 and opposite is -2. That makes square root of 13. And you could go on from there. All right. Now let's do some general solutions. This is what we did yesterday. So for each equation, find the general solution and the particular values. So you're still going to, that first step of yesterday was match it up to a sum and a difference, but we're not using sum and difference anymore. We're using double angles. So you're just going to match it up to whatever you can. So looking at this side, what is the closest thing it matches up to? So look at your sum and difference and match it up, or your double angles, and try to match it up. So the closest thing that I see is 2 sine x cosine x. But it's not quite 2, is it? It's 4. Well, that's just a coefficient. The coefficient is 4, which you could say is 2 times 2. That's what 4 is. So if I wanted this to be a 2 instead of a 4, I would divide by 2. But we can't just do that on one side. We do have to do it on the other. And so now this becomes 2 sine x cosine x, which equals 1. Okay? So don't just always divide by a coefficient. Make that work into the coefficient that you want to see. Because now I can say, well, this matches exactly to sine of 2x. Okay? All right, so our general solutions. Well, if I take inverse sine of both sides, then I get 2x equals inverse sine of 1. And I know that inverse sine of 1, so what this is saying is, where's your ratio of sine 1? Well, sine is opposite over hypotenuse, so that's not going to be a real triangle. But does it happen at all? Is your opposite 1 and your hypotenuse 1 somewhere on the unit circle? So yes, it is. It's up here on the y-axis, which is the 90-degree angle, or pi over 2 radians. So, does it happen anywhere else? Remember, general solutions usually has 2 answers. But for the axes, we were kind of special sometimes because we only got that 1 answer. So this is one of those times that you only have the 1 answer, even though it is sine. All right, so 2x equals pi over 2 plus or minus 2 pi n. Divide by 2, and we get pi over 4 plus or minus 2 pi, nope, divide that by 2 also, so pi n. All right, so that's my general solutions. And then if I want some particular values from 0 to 2 pi, well, pi over 4 is between 0 and 2 pi, so that's one answer. And I'm totally out of space here, so I'm just going to have to come down here. So part B is pi over 4. Now, if you add pi to pi over 4, is that less than 2 pi? Well, sure, because it's only 1 pi. Adding to pi over 4 makes 5 pi over 4. Now, if you add it again, you'd get to 9 pi over 4. Is 9 pi over 4 bigger than 2 pi? And yes, it is bigger, so this is where I'll stop. Okay? All right. Let's go on to the next example. So I'm going to erase all this. Make sure you have it. All right, so let's go on to 2 cosine squared theta minus 1 squared degrees equals negative root 2 over 2. All right, so if you match this up, this is actually a really easy matchup. Do not make this problem harder than it is. Before you start a problem, see if it matches. So I got to pull up my formula chart here. My formula chart says that this entire thing exactly is cosine 2 theta. It matches perfectly. There's no changing I need to do. There's absolutely nothing I need to do. It matches perfectly to cosine of 2 theta. And I'm going to go ahead and change that to 1 over root 2. Negative 1 over root 2. All right, so I can inverse cosine. And my answer from here, well, I actually have 2. I don't know why I drew that right there. So I have the answer in quadrant 2. So that's, what angle is that? Go ahead and think about that for a minute. So you get that that's 3 pi over 4. And also in quadrant 3, and that's 5 pi over 4. Why am I doing radians? Oh, it's irritating. Degrees. Degrees, degrees, degrees. I even said that earlier. 135 degrees. And then, we don't talk about this one that much. 180 plus 45 is 225. Alright, so 2 theta equals 135 plus or minus 360n. And 2 theta equals 225 plus or minus 360n. Now divide by 2, and that's not a whole number. I don't really care if you leave it as 135 over 2, or if you say, what would that be closest to, 67.5? I don't know about that, so I'm just going to leave it as a fraction because I don't mind fractions. So theta equals 135 over 2 plus or minus 360 over 2 does divide, so that's 180 n. And same thing here, 225 over 2 plus or minus 180 n. Okay. All right, let's go on. Double angle properties work whenever the argument is twice as large as the other. So sine of 14x you could rewrite a sine of double 7x. Well, this is sine of 2a. So a is 7x. Well, double sine is, let me just write this here, 2 sine a cosine a. So that's not the answer. I'm just writing out what the identity is. Sine of 2a's identity is 2 sine a cosine a. Well, so I'm going to rewrite my problem as 2 sine, and a is not a is 7x times cosine 7x. All right? All right. Write tangent of 26x in terms of tangent of 13x. Well, tangent of 26x, you could say is tangent of 2 times 13x. So looking at your formula chart, we've got, so I'll write this in black, tangent of 2a equals 2 tan a over 1 minus tan squared a. Now, if you're wondering why I'm not doing sine over cosine, it's because it told me to write it in terms of tangent 13x. It didn't want sine and cosine. It wants tangent still. So I'm just doing what it tells me to do here. All right, notice that a is 13x. So where I see an a, I'm going to put in a 13x. So 2 tangent 13x all over 1 minus tan squared 13x. You're not actually getting an answer here. You're just rewriting it. This is a double angle identity that's equivalent to tangent of 26x. But now I've wrote it with tangent of 13x, which is what it asked me to do. All right, and then lastly, cosine of 10x is equal to cosine of 2 times 5x. So this is a little bit trickier, but it really isn't because it tells you what to write it in. Remember that it tells you in terms of sine of 5x. The problem is that when you look at your double angle, you could say, well, cosine of 2a is equal to cosine squared a minus sine squared a, or it's equal to 2 cosine squared a minus 1, or it's equal to 1 minus 2 sine squared a. Now, which one of these identities only has sine? Well, that's this last one I wrote. So this is the one I'm going to write. So let me just write it again here so that I can kind of match up exactly what I'm going to write. So a is this 5x. So when I rewrite it, I'm going to rewrite with 5x. So my answer would be 1 minus 2 sine squared, and then 5x is my argument. All right, and that's all.